Hi everyone, for this question they say the graph show the area enclosed by the curve y minus 2 squared equals to x and the line x equals to 2. Find the area enclosed by integration with respect to y and respect to x. So firstly we have to identify the area enclosed by the curve and the line. So the area enclosed by the curve and the line will be fall on this region. So for the first question, when you want to find this area by integration respect to y, means we are integrate from the lower limit up to upper limit. When respect to y means dy, the function also need to change in terms of y. So when you're finding this in dy, means we're going to see this region in horizontally. So we can notice that we are two curve concept where we can see this is our first curve in orange color, and then this is our line x equals to 2. So when we're doing horizontally dy, we can notice that it always having the curve from the right hand side green color touch to the left hand side orange color. So our formula here supposed to have two curve concept, which is fy minus gy. So to find this, we need to find out what is our lower limit and upper limit. So substitute x equals to 2 into the curve y minus 2 squared equals to x. So y minus 2 squared equals to 2. When you move the square, it will be positive negative square root 2. So y will be positive negative square root 2 plus 2. So for the upper limit, is supposed square root 2 plus 2. For the lower limit, will be negative square root 2 plus 2. So therefore, our area will be integrate start from negative square root 2 plus 2 up to square root 2 plus 2. And then the function at the right hand side, x as a subject, y equals to 2. So x equals to 2 minus the function at the right hand side, the left hand side. So the left hand side here is this. When x as a subject, it will be y minus 2 squared. Then we can start integrate. For this, integrate 2 with respect to y, it will be 2y. For this, a bracket of y in a linear, so power plus 1 over new power, the coefficient y is 1. Upper limit square root 2 plus 2, lower limit negative square root 2 plus 2. Then what we need to do is substitute upper limit. Minus lower limit. Then we simplify this. It can give us 8 sub 2 over 3 by using calculator. Then we continue for the part 2. Where for the part 2, they ask to find the enclosed area by integration respect to x. So when we do in respect to x, we need to observe this in vertically. So you can notice that the curve is touch back the curve, so we cannot integrate directly like that. So maybe another suggestion way will be we separate this area into half. So when we separate this area into half, we only calculate this region. We calculate this region for integrating respect to x, then we going to times 2 because this is our parabola shape. So y equals to 2 is their symmetry axis. So to finding this area, it will be 2 times the region. So the region here will be integrate start from lower limit, which is 0, up to upper limit, which is 2. And then when we want to calculate these two regions, you can notice that it will be two curve concept. Firstly will be the parabola, then down here will be the constant graph y equals to 2. So to find the integration respect to x, we need to rearrange the function as y to be the subject. So y minus 2 will be square root of x. So y will be square root of x plus 2. So the function, the graph at above, it will be square root x plus 2 minus the graph at below here, it will be y equals to 2, so that we can integrate respect to x. Then we start integration. Integrate square root of x. We can rewrite it. So we rewrite this square root of x to be x power 1 over 2. Then when we have 2 minus 2, we simplify, it gets 0. So now we can start integrate power plus 1 over new power. Then upper limit 2, lower limit 0. So this is 4 over 3. So inside here will be 2 to the power 3 over 2 minus 2 to the power 0 to the power 3 over 2. So this also gives us x sub 2 over 3 unit square. Then we see what is important here for this question. The first step in doing area is form the formula of the area. So by forming the formula of the area, we have to see your integration respect to dy, then function, lower limit, upper limit. Then the next step will be the concept of integration and substitute of upper limit minus lower limit. Final answer will be your value. Then for the second part, also formulate your area correctly. Upper limit, lower limit, the function at the top minus the function at bottom, then dx. And then integrate, substitute your limit. Lastly, final answer.